Hello everybody, Jack Sheffield here, Jack the Exam Guy. We're going to be talking about a roof calculation here. This is actually just a little piece of a video introducing another video that's going to play immediately after this one. And what I wanted to tell you is that that video was recorded before the 32nd edition of the Walkers was available. So if you're in the 32nd edition of the Walkers, you're going to be on pages 471, 472. And as the video says, if you're in the 31st edition, you're going to be on page 788. Same information either way. If you're in another edition of the Walkers, you're just going to have to look it up in chapter 7, which is thermal and moisture protection. Okay, well, here we go. Now, if you are not in the 31st edition, it's not going to be too hard to find what page you need to be on. Just go to the index, look under roof estimating, roof calculations, roof area, something, flat area factor, something along those lines, and you'll be able to find where you need to be. The chapter is called Thermal and Moisture Protection. For some reason in the Walkers, they don't call it roofing chapter. They don't call it roofing. They call it Thermal and Moisture Protection. Well, because they also talk about waterproofing and that type of thing in this section. So anyway, so what I want to direct your attention to, this is what's most important. On page 788 in the 31st edition, and I'm sure they're using this same, whatever edition that you may have, I'm sure they're using these same diagrams and this same chart. So we know that when we figure this calculation and we get our flat area based on our plan view, that we have to adjust it based on the slope of the roof. And that's what this chart is about. Okay, so we're going to get what they call the flat area. Let me get my pointer out here. So this is the flat area. Okay, this is when we do our calculation originally, 68 by 62.5, and then we take this little area out here. That's what we call our flat area. Okay, of course, the roof's not flat, right? Okay, so it's got a slope of 5 and 12. So we're going to go to this rise and run, and we're going to go down to 5 and 12, and it says multiply your flat area by 1.083. It's really just that simple. A couple of things I want to point out to you, though. Unless the question actually uses the word pitch, do not use this column. Okay, pitch is different than rise and run or slope. Rise and run, they talk about it as slope. Pitch is something different. Pitch is based on the entire span of the roof. You know, a typical roof has a ridge in the middle and it slopes to the left and it slopes to the right. Well, when you're talking pitch, you're taking into account the entire expanse of that roof from wall to wall, not just from the ridge to the wall. Rise and run is slope, and that's really just from the ridge to the wall. So be aware of that and try to stay away from this first column, pitch, unless they actually tell you in the question that they're giving you the pitch. Okay, so we're going to concentrate on rise and run, 5 and 12. 1.083 is our factor. Okay, for now, we're going to disregard this last one. This last one is all about hips and valleys. Well, we're not talking about hips and valleys now. We just want how many squares of shingles. That's going to be the most basic type of question and probably the one you're going to get. So we'll jump on over. We're going to do our calculation. If you want to go ahead and figure this out and tell me how many squares of shingles there is, that'd be great. Okay, and what we're going to do is we're also going to have a 10% waste factor. So keep that in mind. We're going to talk about we're going to add 10% for waste. It doesn't say so right here, but that's what we're going to do. Okay, and you can hit the pause button if you like and go on and answer this question, or if you want me to just walk you through it, then that's fine too. So here we go. So this is the way they do it in the book, is they take the 68 feet and they multiply it times the 62.5 feet. Now remember, we got to use 62.5 because everything really needs to be in the same units, which is feet, 62.5 feet. So we multiply that, we get 4250. And because this roof is a nice rectangular shape with just a little kick out here that needs to be subtracted, we can calculate it that way like they did in the book. 20 by 30 for this area, we subtract out, and we get 3,650 square feet. And this is before we adjust for the slope, right? Don't use the word pitch, use the word slope. Okay, so here we go. Now what I did here is I wanted to figure this out a different way because we may not get a nice rectangular kind of a roof on our exam. So we just want to I just want to figure it out a different way. So what I want to just take each section separately. So if we had an imaginary line that ran right up along like this, and we were going to calculate this area, it would be 48 times 62.5, okay, which is 3,000. And then we'd have this area over here, which is 20 by 32.5. Now, if they didn't give us this dimension, we could say, okay, well, this is 68 and that's 48, so this must be 20. So this area is 20 by 32.5. And then we take 3,000, we add 650, we get 3650. Either way you do it, you still come up with 3650. I just wanted to kind of show you that. Okay, you could have done that either way. All right. Now remember, what number are we looking for a 5 and 12 flat area factor 1.083? All right. So we just take that 3650 times 1.083. We get 3952.95. We'll just call that. That's pretty daggum close. We'll call that 3953, and we divide it by 100. Well, why do we divide it by 100? Because a square in roofing is 100 square feet. It's 10 by 10 is a square. Okay, so if we're asking for squares, however many square feet you get, you divide by 100. So we have 39.53 squares, and then we multiply it times the 1.1 for our 10% waste, and we have 43.48. And if you like, you can check the book, and that's exactly what they did in the book, and they got 43.48 squares, and that's on page 789 of the 31st edition of the Walkers. Kind of checking our math there. Okay. Hey, how about that? That's no big deal, right? Well, let's move on. Okay, so I've got another roof here. I want you to tell me how many squares of shingles will be needed for this roof and just round off to the next whole square. Now, I didn't ask you for waste, so you don't have to add waste. If they don't ask you for waste on the test, don't add it. If they do ask you for waste, of course, you add it. Just whatever they tell you to do, you want to do. You're going to be very, very compliant on test day. All right, so if you like, you can hit the pause button and see if you can figure this one out. And if not, then I'm getting ready to walk you through it right now. Okay, so here we go. We get our 30 by 55, yep, and we get our 45 by 30. Okay, this is 45 here because how do we know that's 45? Because it's 75 all the way from here to here. It's 30 from here to here, so it's 45. Okay, so it's 45 times 30. And then our factor from our table, and you can look in the book, our factor from our table is 1.158 for a 7 in 12. Don't say pitch, it's slope. Okay, it is slope. There you go. So we're going to go on and we crunch our numbers. 1650 plus 1350 is 3,000 times 1.158. 34.74, 3474 square feet divided by 100, 34.74 squares, and so we're going to round up to the next one, which is 35 squares. Not a big deal. Okay, we can do this on test day, can't we? All right, now here's another one you might get. Okay, so let's say how many feet of eave metal will be needed for this roof? Allow 4% for laps and drops. We still got this same roof, okay? And if you think you can answer this, then hit the pause button and then come back and see if you got the right answer. We're going to measure the eave metal. Okay, so I'm going to explain this a little bit. This is not complicated, obviously. You have eave metal going down. This is flat. Piece of eave metal here, piece of eave metal here, piece of eave metal here. and here. Now, on our gable ends, now these are gable ends, okay? If you've seen enough plans, you realize that this is a gable end. It is not a hip, okay? So there is a slope here. Then there's a factor that we have to apply to this 30 feet and that 30 feet. And it's the same factor as your flat area factor, okay? So these two sections have to get the adjustment factor. Okay, so we'll move right along. And then, so it's a 7 and 12, once again, 1.158. We're not doing a hip or a valley. This is not a hip or a valley. This is an eve. All right, and we're going to use the same flat area factor adjustment. Okay, so we get 55 and 45 here, and we get 30 here, and we get 25 here. How we know that's 25 is because we've got 30 minus 55. We got another 45 right here, okay, and then we account for our two rakes, our two eaves or rakes, either one you want to call it. 30 feet times 1.158, same flat area factor, and then we have two of them. And then we just crunch the numbers. There we go, 269.48, okay, 200 and, oh, we got to add our 4%. That's what that laps and drops meant, okay, you're going to have some lapping and you're going to have some that, some cutoffs. Okay, 280.25, and the answer is 281. Okay, very good, very good. Okay, we're going to do one that you may or may not see on the general builder or residential, but you could see it, so it's worth taking a look. You'll probably see this, you could easily see this on the roofing exam if you're going to take that. How many feet of hip and ridge are there on the roof? Okay, so if you think you can do this, then go ahead and hit the pause button and give it a shot. Otherwise, I'm going to walk you through it right now. Okay. How many feet of hip and ridge? Well, we obviously have a ridge right there, 55 feet. We have a ridge here. How long is that? Well, this whole thing is 75. This is 30, so it's 45 from here to here. If it's 45 from here to here, doesn't it stand to reason that it's 45 from here to here as well? Okay, yeah, it's just moving it that way. 45, so we got 55 and 45, okay. And then now here's where we've got an issue right there. How about this hip? Now this is a valley. You don't have to worry about the valley, even though the calculation, the adjustment factor is the same. So let's take a look. So it's a 7 and 12 when we're figuring out hips and valleys. It's 1.530. That's a significant difference. So you might want to make it that 1.530. Now you know that. Do you want to hit the pause button and see if you can figure it out? You could do that if you like, or you can just wait for the explanation, which is going to begin right now. All right, so 55 plus 45 plus 15. Now, it's 15 from here to here and 15 from here to here. I didn't have to break them up. It's just really 30. That's going to work as well. But it's the common run, which is the horizontal measurement, is what the number you use to apply the flat area, the hip and valley factor. It's not the flat area factor, it's the hip and valley factor. Okay, so remember it's 1.530 times 2, so it's 100 plus 45.9, 145.9 feet of hip and ridge. That's where you do that. That's a lot of fun. I love doing roof calculations because I know I can get them right and move on and pass this exam. And